Welcome back. Today we are going to observe the remaining fabrication process after photolithography. Okay, in the last class we have seen after photolithography and etching, we opened a window in oxide. Is it clear? This is the last class step. After this, that means after opening a window in an oxide, that means after fourth step, now we have to move to the fifth step, that is gate oxide. Okay, that means we have to grow a gate oxide, that is, which is also called as gate oxide. Okay, this step is also known as growing a thin oxide. Growing a thin oxide. Is it okay? Okay, now see, observe how we are going to grow a thin oxide. This is opening a window in an oxide. Okay, now we have to grow a thin oxide. Now I will use different color for indicating this. Okay, this is a thin oxide. I already said in the last class, this thin oxide should be equals to 1 by 10th of your thick oxide. Is it clear? Now observe very carefully. Here in this portion, I required this thin oxide in this portion itself. In the remaining portion, I don't want this thin oxide. Then what should I have to do? Will you please tell me what should I have to do? Absolutely. I have to repeat step number 3 and step number 4, that means photolithography and etching process. Is it clear? In the same manner how we had done in the previous class steps. Is it clear? Then after that, I would like to maintain this gate oxide in this place. I would like to remove this gate oxide here. I hope that are you clear. Now if you observe that how this structure will be looks like, this is your substrate of p type and this is your thick oxide opening a window in an oxide, and here I would like to use some other color for indicating this is your thin oxide. I hope that are you clear. This is your thin oxide. Okay, this is your thick oxide. Is it clear? This is known as growing a thin oxide, or you may call it as a gate oxide. Is it okay? Then after that, remember very important point. After growing a thin oxide, this thin oxide is especially used for which purpose? Absolutely, it is especially used for forming a gate terminal. Is it clear? Therefore, we are going to use the next step, that is the sixth step here. Okay, the sixth step name is chemical vapor deposition. Is it clear, all of you? Okay, the name of the sixth step is chemical vapor deposition. We have to deposit, okay, chemical vapor. The sixth step is CVD. I already said what is the vapor we are going to use for that. Polysilicon. Okay, for that I am going to use a different color. Observe very carefully. I am going to deposit a polysilicon here. It looks like. Okay, now if you observe that where our polysilicon should be available, only it should be available in this place. I hope that are you clear. It should be present in this place, and in the remaining positions it should not be present. Then what should I have to do once again? Absolutely, I have to do photolithography and etching process. Don't forget, before doing photolithography process, you required a photoresist. After that, you required a photo mask, and you should expose with UV light. I hope that are you clear. Now after photolithography and etching process, how the structure looks like, anybody? Yeah, absolutely, the structure will be like this itself. Let us consider this is your p substrate. Okay, this is your p substrate. This is your, absolutely, what is that? Oxide, thick oxide, and you required here a gate oxide in this place. This is your gate oxide. On that gate oxide, what is the thing present? Absolutely, a polysilicon is present. Is it clear? That means you can call this one is as gate. Is it understood? This is your polysilicon, and what is this one? Absolutely, this is your thin oxide. I hope that are you clear. This is your what? Thick oxide. Is it understood? Okay, after that, very important step after this chemical vapor deposition, the seventh step, which is known as diffusion. Okay, diffusion. This is a very important step. In the step diffusion, first of all, important step you have to remember, you should heat your substrate. You should heat your substrate to a high temperature. Okay, then you have to expose, okay, n-type impurity gas. You have to expose n-type impurity gas. This is an n-type impurity gas. N-type impurity gas. Can anybody try to tell what is the n-type impurity gas? Okay, just go to the, okay, social media and try to search that. I hope that for a p-type there is a boron, for n-type there is an arsenic gas. Okay, observe very carefully. And after that, because of heating this substrate, and because of this gas exposed here, what happened means, okay, due to this chemical reaction, this diffusion, that means this doped n-type impurities will be formed like this, will be aligned in this fashion. I hope that are you clear. Don't forget the doping concentration should be very high. Okay, since they are going to align in this fashion automatically, it is known as self-aligning process. What is the process name? Self-aligning process. I hope that are you clear, all of you. Okay, that means the structure looks like in this fashion. Observe very carefully. I would like to draw one more time the structure very cleanly. This is your substrate of p-type, and this is your thick oxide. I hope that are clear. And if you observe that this is your thin oxide, and this is your, what is this, polysilicon, absolutely. And this is what, absolutely, okay, n plus. I will use different color for this, it can be easily visible to you. Okay, this is your, absolutely, what is this, n plus, n plus. I hope that are clear. Now if you observe that after diffusion, what is happening here, there is a contact, there is a contact here. Therefore what should we have to do, we have to cut this contact. Therefore the next step is what is the next step, that means eighth step. Okay, creating a contact cut. We should create a contact cut. Okay, or you may call creating holes, contact holes. I hope that are you clear. Now what should we have to do means, once again we have to use a thick oxide here like this. Okay, now I would like to observe that here I require the thick oxide in this place, in this place, and in this place. Okay, and in this place. I hope that are you clear. Okay, only this place, this thick oxide should not be available. This place, this thick oxide should not be available. This place, this thick oxide should not be available, should not be available for proper isolation. I hope that are you clear. Now if you observe that, what should I have to do once again to acquire my picture? Absolutely, I should do photolithography and etching process. Don't forget, okay, you should do photolithography and etching process. And don't forget, before doing photolithography you should use photoresist, after that you should use photomask, after that you should expose UV light. Okay, in etching process which acid you are going to use? Absolutely, what is the acid name? Hydrofluoric acid. I hope that are you clear. After this, if you observe that your structure will be looks like in this fashion, if you observe that the structure will be looks like in this fashion, this is a p substrate, and this is your previous thick oxide. And if you observe that the gate oxide will be like this. Okay, if you observe that this is your polysilicon, sorry for that. Okay, this is your polysilicon. I will draw one more time. This is your polysilicon. After that you are having a diffusions here like this, n plus, n plus, n plus diffusion. After that we created once again contact cuts. This should be like this. Absolutely. I hope that are you clear. Now here if you observe that in this place you don't have a thick oxide. That means silicon dioxide for insulation. Therefore it is already isolated. This already isolated. I hope that are you clear. Okay. Now what is the last step we are having? Metallization. What is the last step we are having? Metallization. What is a metal? I said to be used in this fabrication process? Aluminium metal. Absolutely, absolutely, guys. Okay, this process is known as metallization. Are you clear, all of you? Now the ninth step, that is metallization, is the ninth step. Here if you observe that in this step, okay, I will use different color for this to indicate the metal. Just observe very carefully which color. Yeah, okay. Now in this step I'm going to use like this a metal. This is the metal. Okay, this is the metal. And if you observe that where your metal should be available, yeah, absolutely, in this place, in this place, in this place. That's it. In all the remaining places it should not be available. Therefore how it will be? Okay, if you observe that it should be like this. If you observe that it should be like this only. This area, this area and this area. Then you may call this one as gate, you may call this one as source, you may call this one as drain. Okay, this is the step which is known as metallization. Metallization. I hope that are you clear, all of you? This is known as fabricating Nmos technology. Is it understood? Here, if you observe that in this fabrication process, what we had done, if you observe that here from source to drain, you don't have any channel. Here, no channel is there. Okay, therefore you have to enhance this channel. We have to enhance this channel. Therefore, this type of fabrication is known as enhancement mode Nmos transistor. Enhancement mode Nmos transistor. I hope that are you clear. Now to get depletion mode Nmos transistor, to get depletion mode Nmos transistor, what should we have to do? Is it clear? I will tell in this class itself. Observe very carefully. Very important notes. For depletion mode Nmos transistor, for depletion, this D stands for depletion mode Nmos transistor. Okay, we should create a channel in the fabrication itself. Create a channel. Okay, in the fabrication itself, we have to create a channel in fabrication process itself. I hope that are you clear. Now to create a channel in the fabrication process, after opening a window in an oxide, opening a window in an oxide, after opening a window in an oxide, that means I'm going to recall that this is a p substrate. After this step I'm talking about, after opening a window in an oxide, we have to do one more extra step. That extra step is known as ion implantation. Ion implantation. Ion implantation. That means after opening a window in an oxide, okay, which channel you would like to be present? Nmos means N channel. Which channel you would like to present? N channel. Then once again we have to, here we have to do diffusion. We have to heat the substrate to a high temperature. Then we have to add a gas of N-type impurity. Then there is a channel like this. I hope that are you clear. This type of MOSFET is known as depletion mode. After this, the remaining steps are common. Okay, that means gate oxide, growing a thin oxide. After that, you should perform CVD. Okay, then after CVD, you should perform once again diffusion. After diffusion, you should perform creating a contact cuts. After that, metallization. The remaining steps are same as usual. Just the only difference for enhancement mode, and depletion mode Nmos is, in enhancement mode we do not have any channel in the fabrication process. In depletion mode we are having a channel in the fabrication process. The only extra step for this is ion implantation, that should be after opening a window in an oxide. If you observe that how the structures will be looks like, okay, now this is, okay, p type substrate. I'm going to talk about enhancement mode. Okay, and for this I have used this color. Okay, then for polysilicon I have used a red color, and for diffusions I have used this one. Okay, not this one, I think this one. Okay, for metal I think so I've used this one. Sorry for that, before that we should have a contact cuts, right? Yeah, there we are having a contact cut. Okay, then for metal this one we are having this one, and this is gate, this is source, this is drain, gate, source. Okay, now for this is enhancement mode Nmos. If you observe there is no channel here, there is no channel. Okay, now for depletion mode, if you observe that I am going to draw with a single color itself. You observe this is your substrate, and this is your, I will use for this a channel. Here you are having a channel. First of all I would like to draw gate oxide polysilicon like this. This is a gate oxide, and this may be a polysilicon. Okay, and this may be diffusions n plus, and here if you observe that this may be your channel. Okay, and you are having a contact cuts like this. Okay, after that you are having a what we'll call metal. Okay, don't forget this is also a contact cut I had drawn earlier. Is it clear? And this is gate, source and drain. I will use a different color to represent. This is what drain, this is gate, this is source. Is it clear? This is depletion mode Nmos. I hope that are you clear. If you are having any doubts, you may ask. Thank you very much. In the next class, we will talk about PMOS fabrication process of enhancement mode and depletion mode. I hope that are you clear. This is Nmos technology. Okay. Thank you very much for each and everyone. If you are having any doubts, you may ask. Okay. Thank you very much. Have a nice day. Is it clear?